Okay, we'll now look at question 10. Briefly describe an experiment that shows the order of chemical reactivity of the four metals, calcium, iron, magnesium, and sodium. List the four metals in order of reactivity, the most reactive one first. So, before you start on this question, please ask yourself, okay, for the metals calcium, iron, magnesium, and sodium, how do you know which one is the one that is most reactive? Is there a way to find out? Yes. Okay, first you list down the reactivity series of the metals, starting from potassium, sodium. Okay, in the order, please stop calling me colorful zebra in library. Okay, you will realize that sodium will be the one that is most reactive, followed by calcium, then magnesium, and lastly your I, which is your iron, is the one that should be at the last. So after knowing this, how will you describe the experiment? Okay, bear in mind that you have to describe the experiment and not just writing down which one is the most reactive first, but you already know the sequence from sodium all the way to iron. Okay, so that will help you to answer the question as well. So first of all, to find out the chemical reactivity of the four metals, one easy trick that you can do is to react the metals with water. That will already give you 1 mark. How do you describe it? First, half fill a beaker with water, then place a small sample of sodium into the beaker. Okay, for some of you who have attended the lesson on sodium as a group 1 metal, you realize that sodium, on reaction with water, it will react very vigorously and it will dart around the surface, producing a yellow flame. Okay, the experiment is then repeated with the remaining 3 metals. The next one would be calcium, which you already recognize as the second most reactive metal. Calcium, how will calcium react with water? Okay, if you refer to your notes, you will notice that calcium will react radially to produce calcium hydroxide and hydrogen gas, so it is the next most reactive. So after you know about the 2 metals already, it's time to move on to the third one, okay, which is our magnesium. So how will magnesium react with water? Magnesium, on reaction with water, will react very slowly, but it will also produce magnesium hydroxide and hydrogen after a few days. Okay, this after a few days really shows that it's a slow reaction. Lastly, followed by iron. So how will iron actually react with water? It is the least reactive, okay, because it does not react with water at all. Okay, so you will ask yourself, if iron does not react with water, what does it react with? Okay, so most of you will give me the answer as acid. Okay, so looking at these 4 reactions with water, you will conclude that sodium is the most reactive metal out of the 4, but this is not the end. You have to give a statement telling them that the order of chemical reactivity, okay, is from the most to least reactive is from sodium, calcium, magnesium, and all the way to iron. We have now come to question 10, part B, in which we see bromine Br2 is more chemically reactive than iodine I2. So it says that bromine will react with potassium iodide Ki to displace iodine and form potassium bromide. Okay, so when you see this reaction, you know that this is a displacement reaction and is under the chapter of periodic table, okay, for group 7 elements. So this question asks you to calculate the mass of iodine that is displaced when a solution containing 10 grams of potassium iodide reacts with excess bromine. They even provided you with the relative atomic mass, so you don't have to refer to the periodic table. So first of all, how do you do this kind of question? Since this is a displacement reaction, first of all, you should write down the chemical equation for the whole reaction. Okay, so for the whole chemical reaction, you know that you have bromine that will displace your potassium iodide to give you iodine and KBr. Make sure that your reaction is balanced. Okay, so you go and calculate the number of Br atoms on the left hand side and right hand side, okay, and the number of potassium ions on the left hand side and right hand side to see whether do they coincide such that the number of atoms on each side is actually the same. If you are satisfied with your balance equation, Next, you move on to find out the number of moles. Okay, first things and foremost of chemical calculations is always find the number of moles. Okay, from here you can calculate. Since they give you 10 grams of potassium iodide, that's one information that you have. Okay, you may actually go to your equation and write down the information that you have. So for example, I write here 10 grams. Okay, this is the information that I have. I have the information of the relative atomic mass. So if I have the mass, I have the MR, the next thing that I calculate is the number of moles. So using 10 grams, okay, I divided by the total number of the MR, okay, of the atoms that are involved or the ions that are involved in Ki, and I add them together, I will get the intermediate answer of 0.06024. Okay, bear in mind that here at this point in time I still put it not to three significant figures because it's in between. Okay, this is the answer that is in between. Why? Because in the end they want you to calculate the mass, okay, which is the final answer that you should keep to three significant figures. So after finding the number of moles, what next? How can I calculate the mass then of iodine? Looking at the reaction, since the mole ratio of Ki to I2 is 2:1, okay, Ki here, mole ratio 2, okay, looking at the coefficient, and here for I2 is 1, okay, so 1. So the ratio is 2:1, okay, which I write here, okay, since the ratio is 2:1, hence the number of mole of I2, okay, will be half of that of the moles calculated for Ki. Therefore, you take 0.06024 divided by 2 to give you 0.03012, okay, which will give you the second mark. Then, since you have the number of mole for I2, you can then relate back to your formula to calculate the mass of I2 that's displaced. Okay, first, you take the number of moles of I2, okay, which is your 0.03012, multiply by your molar mass. Okay, bear in mind, okay, iodine is I2, okay, so you have to take 127 multiplied by 2 and then multiply together to give you the answer, which is 7.65 grams. Now, for the last part of question 10, okay, 10 part 2, what element could be used to displace bromine from a solution of potassium bromide? Okay, you know bromine is actually a very reactive substance in group 7. So, in order to displace bromine from a solution of potassium bromide, you have to pick another halogen which is more reactive than bromine. So if you go up the periodic table, a few examples that you could have is either chlorine or fluorine.